Now, a second important question that we may ask when we introduce a basis on the space is the question of representing vectors. So let's see the example here. I find here, given this basis B here, three vectors living in three-dimensional space, all independent. They span R3. Fine. And I'm given this vector v1 to 4, which lives in the vector space R3. Now I want to represent v with respect to the basis B given here. That means I want to find the numbers C1, C2, and C3. But what is the meaning of those numbers? The meaning of those numbers is written on this equation below. These numbers are special because C1 tells me how much I need from the first basis vector here, 1, 1, 0, 1, 1, 0. The C2 tells me how much I need from the second vector, so vector in this basis, the 0, 1, 1, 0, 1, 1, 1. And finally C3 tells me how much I need from 1, 0, 3, the third vector. This is the meaning of these C's. But how much I need so that when I sum everything, I get the odd 1, 2, 4. So I need to solve this problem. But if you pay attention, this problem is equivalent to solve this system of equations. So C1 multiplies the first column, just like you find here. C2 multiplies the second column, just like you find here, and C3 the third. Of course, on the right-hand side, you have this. Fine. So let's solving these problems using our elimination processes and using the pivots. The final answer is 0 to 1. And in conclusion, we can say that our vector v with respect to the new basis B is given by the coefficients 0 to 1. One thing that is important to notice here, well, if v is this column vector 0, 1, 0 to 1, what the heck is 1 to 4 anyway? Well, let me write it in another manner. So the vector v here is 1 times 1, 0, 0 plus 2 times 0, 1, 0 plus 4 times 0, 0, 1. So v with respect to B old, the old basis, which is 1, 0, 0, 0, 1, 0, or 0, 0, 1, is equal to what we have, 2, 1, 2, and 4. This is very important idea. My old basis, my natural basis for R3 are these three column vectors that we have here. And with respect to those, well, I have the coefficients that I started with, 1, 2, 4, which tells me how much I need from this column vector. The 2 tells me how much I need from this old basis vector, and 4 tells me how much I need from this one. So, but if I want to represent this vector with respect to the new basis, so this B new, well, I need to solve this problem and get the C's that I need here. That's it.